Now, the inverse trig function is used to find an angle measure. They can be written in two ways. You can write them as this arc sine, arc cosine, arc tangent. Just put an arc in front, meaning I'm looking for the angle. You can also put this little -1 notation next to any of our trig functions. They mean exactly the same thing. They say what angle measure gives you that value. So an inverse trig function is used to find an angle measure. So let's think for just a minute. In the trig functions, the domain is some measure of an angle. At 45 degrees, we get a ratio of square root of 2 over 2. So that's the way a trig function works. An inverse trig function, we're given that ratio. Here, we have square root of 2 over 2 as an answer. What angle measure gave me that? So that's the difference. So if you look here, the inverse sine of 1/2 is pi over 6. Why? Well, we know the sine of pi over 6 is 1/2, so it switches it. The inverse cosine of -1 is pi. The inverse tangent of 1 is square root of pi over 4, 45 degrees. So it goes backwards. So it's important that we can be able to go backwards. Now, the problem with going backwards is we have so many places that we can land and get a sine value of 1/2. We have millions, an infinite number of places that we get a sine value of 1/2. So what do we pick? So it's very important that we know the restrictions on the inverse functions. Now, what we really have to know here are the ranges. So we only are going to look for answers for a sine between -pi over 2 and +pi over 2. That's going to be the same thing for a tangent. That's going to be the same thing for a cosecant. Here's the difference. Tangent, we can't use the pi over 2's because they are undefined. So these are open circles. Hard to see, sorry about that. And then the cosecant doesn't work when the sine is 0. That's an open circle. But those three are all related. So sine, tangent, and cosecant kind of use the same values. Also, the cosine uses anything between 0 and pi. Cotangent uses the same thing, except we throw out the 0 and pi because that makes it undefined. And secant works the same. It works everywhere but pi over 2 because that makes that undefined. So this is just telling us where we get to look for the answers. It's just narrowing it down for us. So don't make it harder than it has to be. We are either using the first and the fourth quadrant. We're going to call the first quadrant the positives and the fourth quadrant the negatives. You'll notice it goes from -pi over 2 to +pi over 2. And then for cosine, cotangent, and secant, we're using values from 0 to pi. And I'll draw this picture or write this range on the board for you so that you have it to look at. And I also included a unit circle so you had it. Okay, so given the fact that we know that the sine, the tangent, and the cosecant all kind of go together, we're going to just look for values between +pi over 2 and -pi over 2. And then the cosine, the secant, and the cotangent kind of go together. Okay, so I've included that for you. So if we want to answer the questions like example 1, let's look at our first one here. We are looking for a theta. Now, specifically, we are looking for where the sine of theta equals 1/2, and we get to look either somewhere between negative pi over 2 and positive pi over 2. So our answer is either in the first or the fourth quadrant. Well, if we look at our unit circle, the sine is our y value. It is equal to that at pi over 6. So the answer is pi over 6. So I want to see this, and then I want to see the angle measure. And I want you to refer to the angle measure as theta. Okay? So what's this one going to give us? Well, I'm thinking that the sine of theta is negative square root of 2 over 2. The sine is negative. We only have to look here and here. The sine is negative down here. So where is it negative square root of 2 over 2? It is right here. We're not going to call that 7 pi over 4. We're going to call this one positive pi over 4. We're going to call this one negative pi over 4. So this is negative pi over 4. Now let's do the cosine. It's saying where is the cosine? This is our theta, our angle measure. Where is the cosine of that angle measure going to give us an answer of negative square root of 3 over 2? Well, let's look at our unit circle. The cosine is positive here. The cosine is negative here. So if the cosine is positive here and the cosine is negative here, we want square root of 3 over 2, and that would be right here. So 5 pi over 6 is our answer. And then our last one, if this is theta, where is the tangent of theta equal to 1? Now let me just remind you some tangent values for a minute. The tangent of 0 is 0. The tangent of square root of 3 over, no, I'm sorry. The tangent of pi over 6 is square root of 3 over 3. The tangent of pi over 4 is 1. The tangent of pi over 3 is square root of 3. The tangent of pi over 2 is undefined. Okay, so those are some nice tangent values to know. So they said, where is the tangent equal to 1? Well, the tangent is equal to 1 at pi over 4. So the answer is pi over 4. Square root of 2 over 2 divided by square root of 2 over 2 is 1. Let's look at these two examples. Where's the cosine equal to negative square root of 2 over 2? So there's that answer is theta. The cosine of theta is negative square root of 2 over 2 at the pi over 4 that is in the second quadrant. So over here. And so that is 3 pi over 4. And then finally, our last one here, where is the arc cosine negative 2? Now, if we look, the cosine always has to be something between negative 1 and positive 1. Remember, that wave is going between negative 1 and positive 1. So if they say, where is the cosine equal to negative 2, that's impossible. So that's no solution. And if you tried to put that into a calculator, you would get a no solution answer. Let's take a look at this one. It says, evaluate the sine using the inverse sine of 0.97 using a calculator. Now, if it doesn't specify, please make sure it is in degree mode. And if you do the sine inverse of 0.97, only when you hit that second button will that little negative 1 appear. And then that is approximately 7.59 degrees. Okay. Now, in example 3, for the first time we are missing an angle that's on the inside. Well, what do we know? In relationship to where that angle is sitting, this is our adjacent, and this is our hypotenuse. And if we use SOHCAHTOA, adjacent and hypotenuse is a cosine. So I know that the cosine of theta is 9/12. So when looking for an angle measure, that is when we use an inverse trig function. Sorry about that. And so we are going to hit the second button so that the little -1 appears. Make sure it's in degree mode, especially in a triangle. The inverse cosine of 9/12 is 41.4 degrees. Wait, let's write that differently. I'm sorry. The inverse cosine of 9/12 is 41.4 degrees. Now, when a triangle says to solve the triangle, then I want you to make sure all missing sides and angles are accounted for. To find this angle, we just have to subtract from 90. These two add up to 90 because 90 plus this 90 would give us the 180 we're looking for. So let's call this phi. That's a fun Greek letter to draw. Phi then would be 90 minus 41.4. So phi would be 90 minus 41.4 is 48.6 degrees.